Hello, my dear friends. Anyone is in live? Hello, my dear friends. Anyone is in live? Hello, my dear friends. Anyone is in live? Hello, Satvik. Hello. Hi, hi. Still any other? Still any other are there? Any other in live? Only one. Only one Satvik I was seeing. Yes, yes. Hero Jeeters. Hero Jeeters. All calls, preparations, everything has been done. అన్నీ అయిపోయినాయి. All calls preparations, phenols preparations and the test and the questions also we have done. Today we'll see the ethers. Ethers and the questions, and tomorrow evening question sessions we'll do. We'll keep the question sessions. Okay. Okay, fine, fine, fine. Okay, right. Now let's wait. Thank you, Aish. Thank you, thank you. Now, any other in live? If any other in live, just say me hi. If anyone is in live, just say me hi. If anyone is in live, say me hi. Hi, hi, Pranit, hi. I'm good, I'm good, I'm good. Just we'll wait for the 1 minute or 1 or 2 minutes so that the rest others to come. Then after that, we'll start the lecture. Okay, just few minutes we'll wait so that the rest anyone. Oh, thank you, Aish. Good, 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 Aish. Good. Now, civil is also one of the good branch only. It is good only. Right, right, right. Now, now, we'll start the lecture. The last class we have done. Right, 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 right. Now let me minimize over. Right. Now we'll start the lecture. Right. The one who are in the live, once you say me hi, so that I get to know that who are in the live, so that I can start the lecture. Hi Pranita, hi, hi. Done. Right. Now, here today we are going to see the one very important. Hi Satvik, hi, hi. Now, right. Now, today we are going to see the one very important. Now, the questions, only two types of the questions they may ask, but the two types of the questions they will ask you in that form of the IUPSC. They will ask you in the form of the IUPSC, but first we'll clear the content first, then after that we'll go to the which one, the question sessions, right? Now here, whenever if you want to name the ethers, first of all, this is a CH3 O CH3, clear? Now this ethers we call it as a dimethyl ethers. This one we call it as a dimethyl ethers. Or if you want to say me the IUPAC name, here this is a one methoxymethane. Clear? This one is a one methoxy group. Any of the one oxygen you can take it as a methoxy group, and you can say this as a which one, methoxymethane. Right? Now next, here the very one important, very much important compound, that common name for this one is a anisole. This is the one very important compound, anisole. And name of IUPAC, if they ask, we can say it as a methoxybenzene. Anisole or the methoxybenzene also we can say. But many of the students, they will get confused with the one given molecule, that is a CH2O. Clear? CH2O. Now this one we can say it as a epoxy, because these common names are very very important, so that we may not get any difficulty while if they ask any IUPAC. This one is a epoxy ethane or oxyrane. This is epoxy ethane or oxyrane. Done? No. Next. Here now we'll see the preparations of the ethers. Preparations of ethers. Now in the preparations of the ethers, here we can prepare the ethers by the different temperatures. Now these different temperatures will play very very crucial role in the, it will play a very crucial role in identification. Clear? You have to be very careful. The whatever the temperature they have given, depending upon the temperature it will play, right? Now the first one here, by dehydration reaction. By the dehydration reaction, already we have discussed this one very clearly. What if suppose the any alcohol if they have given, if suppose any alcohol they have given. Now this alcohol upon concentrated H2SO4, clear? Concentrated H2SO4, sorry. This concentrated H2SO4 at a different temperatures, at a different temperature. One if it is at the 170 degree centigrade, one if it is at the 140 degree centigrade, one it is at the which one? One it is at the normal 100 degrees centigrade. May I know what are the products we will get here? If it is a 140 or 413 Kelvin, and if it is a 100 degree, what are the temperature? And this is a 443 Kelvin if they have given. One is a propene. First one is a propene. Propena. No, first one is a ethene, right? First one is a ethene. This is two carbons only, not propene. It is ethene. It is ethene. Second one is a diethyl ether. Good, good, good. Second one is a diethyl ether. Second one is a diethyl ether. Right. Last one is a sulfonic acid. Yes, last one is a sulfonic acid. CH3, CH2, SO3H. Now last one is a sulfonic acid. Clear? Now this temperature will play a very, very important role. Temperature will play a very, very important role. You have to be very careful with this one. Right? Now, only the 1 degree alcohols only will give you the ethers. With this temperature, only 1 degree alcohol only will give. That is also you have to be very careful with this one. With this temperature, only 1 degree alcohol. So you can, I will write, if the temperature is 140 degree or 413 Kelvin. Now 1 degree alcohol will give you the ethers. Next 2 degree alcohols will give you the alkene. Clear? Again 3 degree alcohol will give you the alkene only. Okay? Only 1 degree alcohol upon this temperature only will give you the ether. So you have to be very careful with this one. Clear? Right. Next one, by the second type of the reaction that we are going to see, by the reaction with dry Ag2O. If the dry Ag2O, if they have given, now here if it is a 1 degree alkali halide, if they have given CH3 or 1 degree alkali halide, 1 degree alkali halide upon dry Ag2O if they have given, then readily it will undergo SN2 reaction. Now again it will give you the ether and 2 moles of AgX PPT will get. How? Here this R and this is the X and the 2 moles of the R and the X. Now here the Ag2O, right? Now the Ag2O will be in this manner. Just break the bonds. Just to break the bond, you will get the, which one? Ag2O will be in this manner only, right? Now this is a Ag2O. Now if you break the bond, you will get in this manner. Clear? Right. In this manner also we can prepare the Mithun right S22. Good. Right. Now if the moist Ag2O, if the dry Ag2O, if the given means, you can write it in this manner. Wait, I will show you. If the dry Ag2O, if they are given, and the moist Ag2O, if they are given, how to write. If the dry Ag2O, if they are given, dry Ag2O, this is in the manner of dry Ag2O. This is dry Ag2O. If suppose the moist Ag2O, if they are given, moist Ag2O, if they are given, how to recognize this moist Ag2O? Moist Ag2O means nothing but aqueous. Here the OH, here the H, now here the H, here the OH. Here the Ag2O will be in this manner, right? Ag2O will be in this manner. Then just you break the bond in this manner and you just break the bond in this manner. So the moist Ag2O is nothing but it is present in the form of silver hydroxide plus H2O. 2 moles of silver hydroxide and H2O. In this manner you have to be remembered. Okay, moist Ag2O if they are given, it will be present in the AgOH plus H2O. If the dry Ag2O they are given, dry Ag2O will be in this manner. Clear, right? Right. Now, next one. Now the next one, very important reaction that we are going to see, that is a, which one? Williamson ether synthesis. This Williamson ether synthesis, you have to be very careful. Now see the question carefully while they are asking. Whenever the Williamson ether synthesis questions, if they have given, see the question carefully and upon what the data he has given. Clear? Now the data is very important. Now what is the data is very important. Here IUPAC will play very crucial role in that one. IUPAC will play very crucial role. Now what is the IUPAC will play very crucial role means, here many of the students they will think that this reaction will undergo SN1, this reaction will undergo SN2, like that. But I will give you the very key points. If you remember these key points, now whatever may be the question they may ask from the Williamson ether synthesis, you will not make mistake. Now what is that points? Williamson ether synthesis. So Williamson ether synthesis, what are the key points to remember in the Williamson ether synthesis? First key point, by this method we can prepare the symmetrical and the asymmetrical, symmetrical as well as asymmetrical or unsymmetrical, symmetrical and the asymmetrical ethers. Two we can prepare. Done? Clear? Next one, alkyl halides reacts with sodium or potassium alkoxide, sodium or potassium alkoxide to form ethers. To form what? Ethers. Now sodium or potassium alkoxide means RO minus Na plus or K plus. This one we call it as a sodium or the potassium alkoxide. Clear? Now this reaction will follow the this reaction will follow the SN2 mechanism. Blindly believe. This reaction will follow the which mechanism? SN2 mechanism. Now to show the SN2 mechanism, alkyl halide should be 1 degree. Here 1 degree alkali halide upon any strong alkoxide or anything, it will readily undergoes, right? Seniors class Vishnu, yes, seniors class. Nana Vishnu seniors class could intava. Now you want to listen the seniors class also? Right. The next point here, in case of secondary and 3 degree alkyl halides, in case of secondary and 3 degree alkali halides with tertiary alkoxide, sodium or potassium, good night ion, with potassium or sodium tertiary alkoxide. Now here the which one? Elimination is more dominating than substitution. Elimination is more dominating than the substitution. Here this is a very important key point you have to remember. This is one key point you have to remember. Clear? Now order of reactivity of Williamson ether synthesis. First one, 1 degree alkali halide greater than 2 degree alkali halide greater than 3 degree. Clear? These are alkali halides. Right? Now we'll see how the reaction it will be favorable and how the ethers will be prepared. First one, I was taking the one small alkoxide ion, and I was taking the 1 degree alkali halide. 1 degree alkali halide, what it will happen? It will readily abstract this what alkali from the back end, and the halogen's good leaving group, it will be eliminated. Then in this manner we'll get the which one, ethers, and this will follow the SN2 mechanism. Done? Clear? Now next, let's suppose if they have given same alkoxide ion, if they have given this alkoxide ion, and I was taking the, instead of 1 degree alkali halide, I was taking the which one, 3 degree alkali halide. Now this alkoxide ion, if it is want to go and attack from the back end, now we know this is a which one, alkali. This alkalis will be repel. This alkalis will be repelled. Due to that repulsion, what happened? SN1 reaction is not favorable. Clear? There is no any chance of attacking from the back end. Then what it will do? Very fastly, it will take the which one? Whatever the hydrogens it are having for the alkali, whatever the hydrogens it is having for that alkali, now it will readily it will take, and the elimination reaction will be favorable. Elimination reaction will be favorable. Whenever the which one? Whenever the 3 degree alkali halide or 2 degree alkali halide, if they have given, which one is favorable? Which one is favorable? Now elimination reaction is favorable for the 3 degree alkali halide they have given. That's the reason only we have to take the which one, 1 degree alkali halide, to get the more percentage yield of the ethers. Clear? Now whatever may be the how much big size of the alkoxide you may take, how much big alkoxide you may take, but here the alkali halide should be the 1 degree only. If the alkali halide, if it is a 1 degree, very fastly the SN2 reaction will be happen, and the what will get? What will get? The favorable conditions, we will get it as a ethers. Now ethers, very fastly the ethers we will get. Clear? In this manner we will get the ethers. Irrespective of the base or the nucleophile you have taken. Now if it is a 1 degree alkali halide, readily it will follow the SN2 reaction and it will give you the ethers. Is it clear, everyone? The one who are in the live, is it clear? Or any confusion you are having? You are having any confusion, or is it clear? Right. Now we'll see which of the following will give you the ethers. Now we'll see. Now I was taking the one alkoxide ion plus one CH2 Cl they have given. Now what is the product we'll get? Now the same thing. Now with the benzyl chloride, now what it will get? The same thing, with the same base. Now with the bridged carbon containing chlorine. Now what are the products we'll get here? What are the products we'll get here? What are the products we'll get it here? What are the products we'll get it here? What are the products we will get it here? Can anyone? What are the products we'll get it here? If you know, say me the answer. If you don't know, you can give me a question mark. I will say. If you don't know, give me the question mark. I will explain. Anyone? Sir, oxygen without any. This is only the nucleophile, right? This is only the nucleophile. This is only the nucleophile will go and attack. Now whether the nucleophilic substitution reaction will be happen or not, you have to say me. Whether the ether will form or which type of the ether will form. Whether the ether will form or which type of the ether will form. If the ether has formed, which type of the ether will form? In the three cases, no reaction will be happened. May I know the reason? In the three cases, no reaction. May I know the reason? Why in the three cases, no reaction will be happen? In the three cases, reaction will not be happened. May I know the reason why? May I know the reason why? See, this is the vinyl chloride, right? Will the vinyl chloride, will it show the nucleophilic substitution reaction? Will the vinyl chloride will show the nucleophilic substitution reaction? This is pi bond of the electrons will be in this manner, right? Then why it will show the nucleophilic substitution reaction? If it is does not showing the nucleophilic substitution, means how come we'll get the, here this is bridged carbon. Bridged carbon alkali halides are unstable, it will not give you. Then here it is a benzyl chloride also will not give you the substitution reaction. You have to be very careful with this type of the reaction they have given. Clear? Now, right? Right? Is it clear? No. Okay. Now I will write the another type of the question. Another type of the question I will write. Now you have to say me. Now you say me, what is the product you will get? Now, whether the reaction will happen or not, if it is happened, what is the product you will get? Reaction will happen or not? If the reaction happened, what is the product we will get? Second is anisole. Okay. You say me, for the first one the reaction will happen or not, you say me. I will say the product. If you are getting confusion, means I will say the product. You say me just whether the reaction will happen or not. The second one case, whether the reaction will happen or not, you just say me. First one reaction will happen. Why? Because this is a negative charge, right? Okay, no problem. Then if it is eliminated, then what it will get? You will get the product in this manner. Okay, no problem. In this manner it will give, right? Okay. Now. Now. Right. Okay, I will write the one. I will write the one question. Now you have to say me the answer. Okay. Here the one. Which one? One ether they have given. Okay. This is a tetrahydrofuran, THF. This is a tetrahydrofuran. Now tetrahydrofuran upon 2 moles of HBr. It gives A. Okay. A upon NaCN. Okay. NaCN first one. Second one is a KCl. Gives B. Okay. Now this B upon hydrolysis. This B upon hydrolysis. A, B, C. This is C. Okay. Same this B upon LAH. This B upon LH gives D. Clear? Right? Now, what is the C? What is the D? What is the B? And what is the A? What is the D? What is the A? What is the B? What is the C? What is the D? Anyone, are you there trying? Tetrahydrofuron upon 2 moles of HBr, 2 moles of HBr, it will gives A. Okay, fine, fine. Try. Try it from your own, okay? If you are not getting, I will explain. But try it from your own. Try to give the answer. A product. A, you know, right? 2 moles of HBr he has given, right? 2 moles of the HBr he has given. Now the other 2 moles of the HBr. Yes. Good. 1 comma 4 dibromobutane. Yes, A is 1 comma 4 dibromobutane. Here you can see this is first HBr, right? H plus Br minus. Now this lone pair of electron will abstract this one. When this lone pair of electron has been abstracted, here it will get the positive charge, here it will get the H. Done. Then to stabilize this positive charge, what it will happen? This bond pair of electron will be given to the oxygen. Then first you will get the, with the 1 mole you will get in this manner. Then after that again oxygen, it will react with another mole. This OH will be eliminated as a H2O. Then again you will get the PR. So 1 comma 4 dibromobutane. Sorry, dibromo 1 comma 4 dibromobutane. This is A. Then 1 comma 4 dibromobutane upon NaCN and the KCN. What is the B? What is the B? What is the B? What is the B here? A, guys, you got. Then what is the B? What is the B? Are you trying? Or should I say? నేను చెప్పనా? మీరు ట్రై చేస్తున్నారా? Are you trying or should I say? Okay, good. Now the B will be the 1,6 1,6 hexane nitrile. Right. Okay. Right. Now it will be the nitrile. Yes. Okay, good. Next, this one upon hydrolysis, what you will get? This one upon reduction, what you will get? Correct? This is 1, 2, 3, 4, 5, 6. Hexane 1,6 dinitrile. Hexane 1,6 dinitrile. Now, this cyanide upon hydrolysis, what you will get? Cyanide upon lithium aluminum hydride, what you will get? Cyanide upon hydrolysis, what you will get? Cyanide upon lithium aluminum hydride, what you will get? Cyanide upon hydrolysis, what you will get? Cyanide upon lithium aluminum hydride, what you will get? Acidamide. How come acidamide? Second as acidamide. Acidamide के लिए in which one you are saying it as acidamide? Pranit? ఇందులో acidamide. In which you are saying it as a no. Here you know, right? Cyanide upon hydrolysis, amine you will get, not acidamide. Just amine you will get here. No, here this cyanide 1,6 dinitrile hexane. Yes. This one upon hydrolysis, what you will get? This one upon hydrolysis, here the CH2, here the CH2, clear? Here the CH2. Now here this is a, which one? This is a cyanide, right? Cyanide, it will be converted into the carboxylic acid. This cyanide will be converted into the carboxylic acid in this manner. Clear? Now this one we call it as a adipic acid. This one we call it as a adipic acid. Done? Now this cyanide upon which one? Lithium aluminum hydride, it will become the primary amine. This cyanide upon lithium aluminum hydride, both will convert into the which one? Primary amine. Both will be converted into the primary amine. You have to be very careful with this one. This is a primary amine. Now this one upon hydrolysis, both will be converted into the carboxylic acid. This carboxylic acid we call it as a adipic acid. This carboxylic acid we call it as a which one? Adipic acid. This one will be converted into cyanide upon lithium aluminum hydride will be converted into amine. Now cyanide upon hydrolysis will give you convert into the carboxylic acid. So you have to be very careful with this one. Right? Is it clear? Now the next very reactions of the ethers. Now the reactions of the ethers we'll see. Now the reactions of the ethers. In the reactions of the ethers with HX. In the reactions of the ethers with HX. In the reactions with the ethers and the HX. Now the first one, if the symmetrical ethers, if they are given symmetrical ethers upon HI excess. HI excess. The HI excess if they are given, then what it will happen? Now this is R, O, R. Now here this is a HI excess, right? HI excess means here the hydrogen and here the halogen. Now here it is a hydrogen and here it is a halogen. Both because HI is excess. What it will happen? More electronegative will take the less electronegative. More electronegative will take the less electronegative. Less electronegative will take the more electronegative, or it will form the bond. Now in this manner the bond will be broken. Then what it will happen? 2 moles of Rx and H2O will be formed. When if the HI excess if they are given. If suppose 1 mole of HI excess or 1 mole of HX if they are given. 1 mole of HX if they are given, then what it will form? 1 alcohol it will form and 1 it will form the Rx. 1 alcohol it will form, 1 Rx it will form. Done? Right. If suppose unsymmetrical if they are given. With the symmetrical if they are given, there is no problem. If unsymmetrical if they are given. In this manner, unsymmetrical ethers if they are given. Unsymmetrical ethers if they are given, then here HI excess. The HI excess if they are given. Then HI X 1 mole if they are given. Right? Then HI excess if they are given, no problem. How? Same thing. The same thing it will be formed. How? Here the H, here the X, here the H, here the X. Then one alkali halide will go with the alkali halides will go with the which one? Halogen, this one. Halogens will go with the alkali halides and will get the H2O. But if suppose if they have given the 1 mole of the HX, based on, now we have to see the mechanism. Here we have to see the mechanism. We have to see the mechanism and we have to predict the product. We have to see the mechanism and predict the product. Simply we should not say. Simply we should not say. Whenever the which one? Asymmetrical alkene if they have given. Asymmetrical ethers. Right? Now we'll see. Now what are the how to remember the points? Points to remember. These points if you remember, now whatever may be the HI reactions or this HX reactions if they are asking, you will not get any mistakes. First points to remember. Points to remember. Now the first one, if alkyl groups are 1 degree or CH3, SN2 mechanism will be followed. SN2 will be followed. Means 1 degree alkali ethers if they are given. Right? If alkyl groups are secondary, then you have to be very careful with the if alkyl groups are secondary. How the alkyl groups are secondary? This is C. Now this is a CH3. Now here it is a H. Now here it is a O and here it is a CH3. Then here which mechanism to follow? You have to be very careful. Here which mechanism it will be followed? That it will be depend upon the what? Here if suppose concentrated HI if they are given. Concentrated HI if they are given. This concentrated HI if they are given, readily it will undergo SN2. SN2 we know, right? Nucleophile will go and attack to the less number of carbons and rest will be the alcohol. Rest will be the alcohol. Right? Now, if suppose, which one? If suppose dilute HI if they are given. Dilute HI or cold HI if they are given. Dilute HI or cold HI if they are given. That one readily it will undergo SN1 reaction. SN1 reaction, how? Here this CH3 iodine will go and attack to the carbocation which is stable and it will get the 1 degree alcohol. So this is very key point you have to remember. Whenever the it will go and attack to the this is secondary carbocation. So here also not 3 degree. Right. Now here clear. Now, whenever the 2 degree they have given, you have to be very clear with the, which one? Now, cold and the dilute and the concentrated if they have given, now 2 degree only, it will make very much difficulty for us to predict the product. If suppose 3 degree if they have given, 3 degree means blindly you can believe. If the 3 degree alkyl ethers if they have given, the 3 degree alkyl ethers if they are given, what readily it will undergo SN1 will be favorable. SN1 will be favorable. SN1 will be the favorable. Clear how the SN1 will be favorable? Yeah, the first CH3, here the OH, now here the C, CH3, CH3, and here it is a CH3. Clear? Now here it is a HI. Cold HI if they are given, cold SN1 will be readily takes place. How? Now this lone pair of electron will be abstracted this proton. Done. Now here it is a CH3. Now here is the C. Here is iodine. Here the CH3. Here it is a CH3. And the leftover will be the oxygen will get the positive charge, right? Then it will become the alcohol. Okay. These are the one key points you have to remember. The many of the mistakes you are going to do with the 2 degree alkali halide they have given. 2 degree alkali halide concentrated if they have given, concentrated HI if they have given, right? Blindly believe that it will undergo SN2. Cold HI they have given, blindly believe that it is SN1. 1 degree alkali halide given, blindly believe that is SN2. SN2 means nucleophile should go and attack to the alkene carbon which contain less number of hydrogen. 3 degree means blindly you can believe that it can give you the, which one? It can give you the SN1 reaction. Now I will write. Now you have to say me which mechanism it will be followed. You have to say me, right? Now this is a one alkyl ether they have given. One alkyl ether upon HI, right? Now upon HI, aqueous medium, right? One in the presence of acetone. Now here A followed which mechanism, B followed which mechanism also. Or else you say me the product IUPAC names. Product IUPAC names you say me. A followed which mechanism, B followed which mechanism. A followed which mechanism, B followed which mechanism. A followed which mechanism, B followed which mechanism. A has followed the which mechanism, B has followed the which mechanism. A has followed the which mechanism, B has followed the which mechanism. First one is SN1. Yes, good. First one is a SN1 because this is a polar protic. This is the polar protic SN1, right? This is a second one is a polar aprotic. Polar protic solvent. This is a polar aprotic solvent. Yes. This is a PPS. This is a PS. Now you say me the product names you say me. Products names you say me. Or say me the product's name. Say me the product's name. Say me the product's IUPAC name. Say me the product's IUPAC name. 2-iodopropane. Good. 2-iodopropane. Next. 2-iodopropane. Next. 1-methyl iodide. Yes, good. 2-iodopropane, 1-methyl iodide. Good. 2-iodopropane and the 1-methyl. Right, Nana. Good. Right. Right. Next one. Now, next one. The next question we'll see. If suppose next one. Mm, mhm. Right. Now you see me. Now you see me the product. Chai cold. What is the product we'll get? No, what is the product we'll get? What is the products we'll get? And what is the mechanism it has followed? Tertiary iodide. Yes, good. In this case, tertiary iodide will get. In this case, yes, tertiary iodide plus ethyl alcohol. Now, in this case, what you will get? In this case, what you will get? In this case, what you will get? Why you are getting confusion? No, no. How come iodobenzene? See, here you can see this is oxygen. No. Praneeth, listen. This is lone pair of electrons, right? This is lone pair of electrons. And this is having the HI. Okay? Here we are having the HI. Right? Now, if this lone pair of electron, if it is abstracted this proton, then no. Here, if this oxygen will get the positive charge, then here we are having the ethyl. Now, breaking the bond off from the phenyl ring is favorable. Breaking the bond from the ethyl is favorable. Now, here the phenyl carbocation is more unstable, right? Here, from here it is more stable, right? Breaking the from the ethyl, then how come? Then how come the bond will be broken? Now the bond will be broken from the, but actually no, benzyl. How come the benzyl carbon? There is no carbon, right? This is a benzyl, right? This is a benzyl carbocation. This is a benzyl carbocation. And benzyl carbocation kaadu kada na. This is a benzyl carbocation. This is a phenyl carbocation, right? This is phenyl carbocation. Phenyl carbocation is unstable, right? Okay, right. Now, right. Next, here actually the reaction it will not happen in this manner. The reaction will be happen how? The reaction will be happen in the form of HI. In the form of HI, first this iodine nucleophile will go and attack to the ethyl, and this bond pair of electron will be shifted towards the iodine. Oxygen. Then oxygen will get the negative charge, right? That proton it will go and attack, and it will get the ethyl iodide. It will get the ethyl iodide, and it will get the OH. It will get the OH. Now this is a product. Clear? Is it clear? Now the phenol and the ethyl. Now one very important molecule. One very important molecule I will explain for you. Listen carefully. Right? If suppose this one if the given, one O80 if the given. Now HI cold if they have given. HI cold. right? Now, what are the products we'll get in this one, in this question? Will the reaction will happen or not? Will the reaction will happen? If the reaction happen, what are the products? Not ethyl aided, ethyl alcohol. Ethyl alcohol will get. See, here the iodine is not having chance. Here the iodine will be attacked. Now this bond pair of electron will be go. Now ethynyl alcohol, not this is ethyl alcohol, ethynyl alcohol. This is ethynyl alcohol, and you will get the ethyl iodide. Ethyl iodide you will get. One is the ethynyl alcohol and the ethyl iodide you will get. Why you are getting confusion? I was not understanding. Now, one is a ethyl alcohol and one is a ethynyl alcohol. See, one is a ethynyl alcohol and one is a ethyl iodide. Now, this one is a enol, right? It is in the form of the enol, right? This is a enol. Now we know enol, it will do the 1 comma 2 tautomerization will be happen. Now this enol upon tautomerization, what you will get? Now what you will get? You will get the iodine. Sorry, you will get the aldehyde. Actually, this product is very important molecule. This is a very important molecule. You have to be very careful. Clear, whenever this type of the compound they have given, ethyl iodide you will get, and one you will get the enol. Now this enol again upon the tautomerization, it will be converted into the which one? Acetaldehyde. It will be converted into the acetaldehyde. Is it clear? It will be converted into the which one? Acetaldehyde. Is it clear, Praneeth? Right. Now I will write just some molecules, so we will have some idea. So, right. కన్ఫ్యూజ్ కాకు, ఎందుకు కన్ఫ్యూజ్ అవుతున్నావు? చూడు మాలిక్యూల్ మంచిగా చూసి ప్రోడక్ట్ ని ప్రిడిక్ట్ చేయి. టెన్షన్ ఏం లేదు. నెక్స్ట్ ఇంకొకటి రాస్తా, చెప్పు. నౌ అనదర్ మాలిక్యూల్ ఐ విల్ రైట్, యూ ట్రై టు సీ. Now next one, if suppose two phenyl rings if they are given, or phenyl rings with the ethers, okay, upon HI cold, right? Next allyls, HI cold, right? Now one allyl, one is a benzyl, one is a allyl and one is a benzyl. Right? Now what are the products we'll get? Now you see, what are the products we'll get? What are the products you will get? These are the no reaction. These are the no reaction. Right. Because here the carbocation stability are phenol. No, 3 will not give the reaction. 3 will not give the reaction. You have to be very careful. 3 will not give the reaction. No, here the phenol and the iodobenzene, it is not at all chance. That's what I'm saying. The breaking of the bond is not at all possible. 3 of the molecules will not give the reaction. Next one. If suppose next one. If suppose if they are given the in this manner, HI cold they are given. HI cold. Now what are the products you will get? Now if the HI cold they are given, what are the products you will get? What are the products you will get? What are the products you will get? Now, what are the products you will get? What are the products you will get? Three-iodocyclopropene. Ah, yes, because that is aromatic ring. So very fastly the iodine it will go and you will get the ethyl alcohol. One is a ethyl alcohol, one is a 3-iodocyclopropane. Right. Good. For a few seconds, Nana, few seconds I was turning off my camera, but my voice if it is not clear, you just say me. Okay na? నా వాయిస్ క్లియర్ లేకపోతే నాకు చెప్పండి. రైట్. నెక్స్ట్ ఇంకో 2-3 I will write the 2-3 questions. Now you have to say me. If suppose the epoxides if they are given, epoxides. ఒకవేళ epoxides ఇచ్చిండంటే how to do the reactions? How to do the reactions with the epoxides? Now here whenever the 3,4 C cyclic ethers if they are given, cyclic ethers with the HX. If suppose the cyclic ether they are given and if they are asking the HX, then how to predict the products for this one? To predict the products for this one, now you have to be very careful with the reagents they have given. Right now, 3 are 4 membered cyclic ethers. 3 are cyclic ethers are unstable. They are unstable. Right? Due to the angle strain. So they are very high reactive. Clear? They react with base as well as acids. Okay, 3 membered cyclic ethers they have given, they will readily react with the base as well as acids. Means if suppose if they have given, this is the 3 membered cyclic rings they have given. Now what it will do with the HI, with the aqueous KOH, both with the aqueous KOH and with the HI it will be react. Right? Let's suppose if the 5 and the 6 membered rings if they are given, 5 and the 6 membered rings if they are given, with the HI it will be react, but with the base it will not be react. With the base it will not be react because the rim opening. Is it clear? Now here the base it will not be react. This you have to be very careful. Now here if the acidic medium if they are given, acidic medium if they are given, ring open from more stable side. From the more stable side, now the ring will be open and the mechanism will be followed SN1. right? Now the basic medium if they have given, ring open from less steric crowd, from the less steric crowd, it will be append, or the mechanism it will follow acetone. The mechanism it will follow which one? Acetone. Clear? This you have to be very careful with the reactions whatever they have given. Now we'll do the some questions based on this one. Now I will write some questions. You have to be very careful. Now you have to try to say me the answers. Now, right here. Now I will write the IUPAC. You have to say me the name. Okay. Bicyclo 2,2,1 heptane 2 in upon Br2H2O NaOH. Okay, and one is MCPBA. One is MCPBA. Now say me the answers. If you know the answer, say me. If not, I will explain. If you know the answer, say me. If not, I will explain. Now, bicyclo 2, 2. Why? This is a compound, right? ఇది కదా కాంపౌండ్, ఇదే కదా. 1, 2, 3, 4, 5, 6, 7. 2, 2, 1 heptane 2 in, ఇదే కదా. నాట్ గెట్టింగ్ బ్రిడ్జ్డ్ కార్బన్ విత్ 3-membered ring, ఇదే కదా. బైసైక్లో 2, 2, 1 heptane 2 in 4-membered, right? ఎందుకంత కన్ఫ్యూజ్ అవుతున్నావు ఆన్ బోత్ సైడ్సా? చూడు, వాట్ ఇస్ ద ఆన్సర్ యూ విల్ గెట్. వాట్ ఇస్ ద ప్రోడక్ట్ యు గాట్? వచ్చిందా? రాకపోతే నేను చెప్పనా? షుడ్ ఐ సే? Now here you will get the right one Br and one OH will be there. One Br and the one OH will be there, and the MCPBA, right? MCPBA, what epoxide will come, right? MCPBA. In this manner you will get. Ante. Don't get confused. Okay na? Clear? Everyone, is it clear? Right. Pranit, is it clear? Clear enough? Right. Now, by this, okay. Now, ఇక్కడికి ఏం చేస్తున్నా, నువ్వు రేపు మార్నింగ్ వరకు ఓకే ఓకే బై ద మార్నింగ్ ఫిజిక్స్ అండ్ మ్యాథ్స్ అన్ని క్లియర్ చేసేసుకొని ఈవినింగ్ వరకు బై ఈవినింగ్ 7:30 మ్యాక్స్ 7:30 I will start the live on the question session. Okay, question session, completely question session. I'll call Phenols ethers, completely question session. Okay na? Right, 7 or 7:30 I will schedule the live. Try to attend the question session. Hello Captain America, ఇప్పుడు వచ్చావు? Right. I was ending the live. Now we'll see you tomorrow. End చేస్తున్నా live. Questions చేయండి, ఓకేనా? More the number of questions, try to do. Okay, fine, bye.